So this is the robotics capstone course, and we're actually using a humanoid robot and also the Kinect three-dimensional camera as a way to teach the robot new skills directly by observing a human teacher. So it's a way of implementing machine learning and algorithms from artificial intelligence and speech recognition, really implementing them and getting hands-on experience by using them in the context of a real physical robot.
We want to have objects that the now has never seen before in front of the now, and then we want to use the Kinect to detect these unknown objects and then basically have this sort of interactive now learning about what objects are in its world.
What is this object called?
It is called ball.
Did you say ball?
Confirm yes.
Okay, does a ball have any properties I should know about?
Confirm yes.
What is one of its properties?
It has the property round.
Did you say round?
Confirm yes.
Okay, I've saved this property.
Another one of the challenges, and this definitely, I don't think this works perfectly yet, is detecting the difference between an object that you have seen before and an object you haven't seen before. So basically, how do we know that it's a different soccer ball versus the same soccer ball in a different rotation or something like that? And so that's a really tricky problem.
Capstones, you get to bring in a lot of different skill sets and then actually apply it to real problems. And you get to work on one project over the course of a whole quarter, so you can achieve and solve from difficult problems, which I think is pretty much what you're going to be doing after you graduate. You know, you're going to go into industry, you're going to be working at some big firms or even maybe research, and that's what your goal is, right? To solve these big problems that matter to us as humans.
We chose balancing because it seemed like a really interesting and difficult task.
So basically our goal is to get the now to imitate a human's motions while maintaining balance. To do that, we're using the Kinect to read in the three-dimensional positions of all the human's joints. I'm able to see over there, Mike's moving around, and basically what we've got the now doing is reading in those 3D joints, at the same time maintain balance, which is a difficult problem because the dynamics and the distribution of weights of all the now's body parts are different from the human. So if the now directly mimics the human, it's going to fall over. So there has to be a little bit of transformation.
Robots are pretty cool. It's a pretty interesting class. I mean, we get to play with this $10,000 little bipedal robot that's like 2 feet tall.
For our project, we have 2 learning procedures that we were interested in. The first is based on improving the natural language interaction that we have with our robot. So we were interested in being able to speak to the robot naturally and having it understand a little bit about what we were talking about.
Now walk backward.
Please clarify distance.
2 meters.
Yeah, so one of the major advantages of this system is we can say we have a larger scope of the way you can tell the now how to walk. You don't have to always say, now walk, or in that specific way. You say, I want you to walk 2 meters forward.
So basically there was a missing parameter in your command and it asked for that.
Yeah. This is basically the first half of our system. The second half is connecting what we've said and the logic extracted from natural language to actual sensor streams.
Yeah, and then combining with the logic built on each's word level to somewhat program the robot.
Yeah.
Then it's actually logic and sensor stream to actually do some task.
For the natural language side, to interact with it verbally, we have trained a naive Bayes classifier so that given an input sentence, it understands which of its learned environment sort of attributes we're talking about, and then it'll respond to us by telling us about what we're querying, what we're asking about. One of the problems with that is if we want to be able to interact with our robot with sentences that it's not seen before, then we had to have a large set of example sentences, and then we used that to train our classifier. So then the second learning task, learning about its environment, we used what's called a support vector machine. We've used actually a number of them, and we used our natural language to specify positive and negative examples of different attributes that we're interested in.
You are far away from an object.
You asked me about the category distance. I am far.
And with that, we would feed in our entire sensor stream into a support vector machine, which would then, in the future, classify other examples of close or far.
I think it gives the students some experience that they might not have had in other courses, and it gives them a way to test their knowledge of computer science in the context of a humanoid robot.